In this video, we're going to discuss using zeros to solve quadratic equations graphically. So what is a zero? Well, the zero of a function is an input value, or x, that makes the output value of the function, or y, equal to 0. So best way to understand this is to just go ahead and graph this function y equals x squared minus 4x minus 5 and see what these zeros look like. So let's go ahead and start by identifying the different information this function gives us, recognizing that this function is in standard form, meaning in the form of y equals ax squared plus bx plus c, where a is the coefficient of x squared, b is the coefficient of x to the first power, and c is the constant. So we can look here and identify our a, b, and c values. A is the invisible 1 here in front of x squared. B is -4. And c is -5. And if we know the c value, we could also identify the y-intercept, because the y-intercept is the same as the c value. So it is -5. And the reason for that, if you think about it, in order to find the y-intercept, we need to substitute 0 for x. So 0 squared is 0, -4 times 0 is 0. So all of this becomes 0, and what we're left with is -5. So that's why the y-intercept is always the same as the c value. Next, we want to find the axis of symmetry. Remember that parabolas are symmetrical. So the axis of symmetry is that middle, that fold line of the symmetrical parabola, and it's also the x value of our vertex. And the way we find the axis of symmetry is using the formula x equals -b over 2a. So what we want to do is we want to go ahead and write this over using parentheses. So -b over 2 times a, and now we're going to go ahead and plug in our b value and our a value. So our b value here is -4, and our a value is 1. So here, -4, that's +4. And 2 times 1 is 2, and 4 divided by 2 is 2. So our axis of symmetry is at x equals 2. And that is also the x value of our vertex. So we can go ahead and go over here to x equals 2, which is this line, and just draw a dotted line going down so that we know where our axis of symmetry is. The axis of symmetry itself is not a part of the graph. It's just going to help us to draw the graph. Now that we know what the axis of symmetry is, we could use that x value to plug in to this equation and solve for y to find the location of our vertex. So I'm going to use parentheses, always a good idea. So x squared minus 4 times x minus 5. And our x value of our vertex is 2. So 2 squared is 4. -4 times 2 is -8. Minus 5. 4 minus 8 is -4. And -4 minus 5 is -9. So our vertex is at the point 2, -9. And the vertex is always going to be on the axis of symmetry. So 2, -9, that's going to be right down here at this point right here. So this is the location of our vertex. And there's another point we can already place because we already know what the y-intercept is. The y-intercept is -5. So -5 is right here. That's the y-intercept. So now, what do we do for the rest of the parabola? Well, since parabolas are symmetrical, we can find the points for one side and then reflect to find the other side. And since we already have one point to the left of this line, that's what I'm going to do. Now, between this point here, 2, and this point here, 0, I have 1. And the way we're going to do this is we're just plugging in to this x squared minus 4x minus 5. We're going to plug in our x values and solve for the y values. So what if x is 1? So I'm going to find the point 1 comma something. So if x is 1, we have 1 squared is 1. Negative 4 times 1 is negative 4. Minus 5. 1 minus 4 is negative 3. And negative 3 minus 5 is negative 8. So one of our points is 1 comma negative 8. So that's going to be right here. And now we can go ahead and move off to, how about negative 1? So what about if x is negative 1? What do we get? So I'm going to come in here and I'm going to put these negatives, and this is going to change a little bit. So let me erase this. So negative 1 squared is still 1, but now negative 4 times negative 1, that's positive 4, minus 5. So we have 1 plus 4 is 5, and 5 minus 5 is 0. So when x is negative 1, y is 0. And so that's going to be right here. And let's go ahead and do one more point. So what if we go with negative 2? So if x is negative 2, what's y? So let's go ahead and erase this. And we're going to go ahead and plug negative 2 in here. So negative 2 squared, that's 4. Negative 4 times negative 2, that's positive 8. Minus 5. 4 plus 8 is 12. And 12 minus 5 is 7. So when x is negative 2, y is 7. And we could plot that right here, negative 2 comma 7, that's going to be right here. All right, that's as far as we can go. So now what are we going to do? Well, we have the left side of this parabola, and to find the right side, all we need to do is reflect over. So this point here is one step, because this is counting by 2's, right? So this is one step to the left of my axis of symmetry, so its reflection partner is going to be one step to the right. This point here is 2 steps to the left, so its partner will be 2 steps to the right. This point here, 3 steps to the left, so its partner, 3 steps to the right. And this point here is 4 steps to the left, so its partner, 4 steps to the right. So now we can go ahead and graph our parabola. Try our best to make this a smooth curve. So not perfect, but good enough. So what are our 0 values? Well, think about a coordinate plane, and where are the y values always 0? Well, that's on the x-axis. And what do we call any point where a graph intersects the x-axis? We call those x-intercepts. So the x-intercepts here are our 0 values, where y equals 0. So we have one right here, which is at the point negative 1 comma 0. And we have one right here, which is at the point 5 comma 0. And the solutions to the quadratic equation are the x values that give you that 0 for y. So we say that the solution is x equals negative 1 and x equals 5. All right, so let's go ahead and try to solve this quadratic equation, 2x squared minus 5 equals negative 3, by graphing it and finding the zeros. And I encourage you to pause as we go along and try to do this on your own. So now, the first step here that we did not have to do in the first example is, since we're trying to find the zeros, what we want to do is we want to set this equation equal to 0, which means we don't want this to say equals negative 3. We want it to say equals 0. So how can we make this side equal to 0? Well, we just have to get rid of negative 3. And how are we going to do that? We're going to do that by adding 3 to both sides. And so here, negative 3 plus 3 is 0. And negative 5 plus 3 is negative 2. And we have here 2x squared minus 2 equals 0. So now this quadratic equation is set equal to 0. Remembering that this 0 is our y value, now we can go ahead and write this as a function and graph it to find our solution. So we're going to write y equals 2x squared minus 2. So let's go ahead and identify our A, B, and C values. We see here that our A value is 2, and we can see here this negative 2. Is this a B value or is it a C value? Now remember, the B value is the coefficient of x to the first power. We don't see an x to the first power. So this is a constant, and the constant is our C value. So what is our B value if there is no x to the first power? Well, it's 0. And if you don't get that, another way I can write this 2x squared minus 2 is I could write it as 2x squared plus 0x minus 2. And so what's 0 times anything? 0. So 0x becomes 0, and it's not important anymore, right? It just goes away, which is why we don't see the x value here. So our B value is 0. And of course, if our C value is negative 2, that tells us that our y-intercept is also negative 2. Let's just go ahead and put that right here, right now. Here's our y-intercept of negative 2. So now let's go ahead and find our axis of symmetry. Remember that the axis of symmetry, the formula is x equals negative b over 2a. So if I use parentheses here, negative b over 2 times a, my b value is 0, and my a value is 2. Now, if you're paying attention, we don't really need to go any further because my numerator of this fraction is 0, and 0 divided by anything always equals 0. So this is kind of like a little hint we can use. If you're solving a quadratic function and the b value is 0, that means the axis of symmetry is also going to be 0. So whenever your b value is 0, the axis of symmetry, or the x value of your vertex, is 0. And so in this case, our axis of symmetry is the y-axis. And so what is the vertex? Well, we already put it there because the y-intercept is where x is 0. And in this case, our axis of symmetry, x is 0. So in this case, the y-intercept and the vertex are one in the same. So this is our vertex, is at the point 0, negative 2. So now what we want to do is we want to pick one side of this parabola, because remember the axis of symmetry is the y-axis here, and find one side and then reflect over. And then obviously, if you need to choose between negative and positive numbers, the positive numbers are going to be easier for most people to work with, right? So we're going to go ahead and move off to the right. And what we're going to do is plug these in. So my first x value to the right is 1. So 1 comma something. Let's go ahead and find that. And what we're going to do again is we're going to substitute that into this 2x squared minus 2. So I'm going to say, all right, 2 times x squared minus 2. And so we're going to plug in 1. So 1 squared is 1. And 2 times 1 is 2. And 2 minus 2 is 0. So where x is 1, y is 0. So then how about 2? So 2 comma something. Well, let's go ahead and erase this. And plug in a 2 here. So 2 squared is 4. 2 times 4 is 8. And 8 minus 2 is 6. So where x is 2, y is 6. And I don't think we're going to have room to place another point. So we have 1 comma 0, which is right here. And we have 2 comma 6, which is right here. And so now our y-axis is our axis of symmetry, so we can just reflect. So this point is 1 to the right of the y-axis, so its partner is going to be 1 to the left. And this point is 2 to the right of the y-axis, so its partner will be 2 to the left. And so we're going to go ahead and do our best job to graph this parabola and take a look at our x-intercepts, which give us a y value of 0. They are right here and right here. So this point is at negative 1 comma 0, and this point is at positive 1. comma 0. And so those are our x-intercepts. Those are our zeros. And remember, the solution is the x value that gives you those zeros. So x equals -1 and x equals 1. All right, so let's take a look at this quadratic equation. 6x plus 8 equals -x squared. Remember, we want to set this equal to 0. So in order to get rid of this -x squared, in order to make this side equal to 0, I need to add x squared to both sides. So -x squared plus x squared, that leaves me with nothing or with 0. And over here, there's no combining, so I end up with x squared plus 6x plus 8 equals 0. And in order to graph this, we're just going to rewrite this as a function. So y equals x squared plus 6x plus 8. So now let's go ahead and identify our a, b, and c values. Our a value is 1, our b value is 6, and our c value is 8. That tells us that our y-intercept is also 8. Now let's go ahead and find our axis of symmetry, which is the x value of our vertex. Remember, we use x equals -b over 2a. So set this up with my parentheses. My b value is 6 and my a value is 1. So this becomes -6 over 2, which equals -3. So I now know that my axis of symmetry is at -3, and so that's going to be right here. This is -3. And I also know that this -3 is the x value of my vertex. So now I'm going to use the x value of -3 to plug in and solve for y, so I could find the y value of my vertex. So -3 squared is 9. 6 times -3 is -18 plus 8. So 9 minus 18, that's -9. And -9 plus 8, that's -1. So the vertex is at the point -3, comma, -1. And we can go ahead and plot that right here, -3, comma, -1. That is going to be right here. We also know that our y-intercept is 8, so I could place that here. And so I already have one point to the right of my axis of symmetry, and I don't think I can go any higher than that. So I'm going to find the values in between -3 and 0. So that's going to give me -2 and -1. And we're going to find those by plugging those in. So I want to find -2 comma something and -1 comma something, right? So first, let's go ahead and plug in -2 here. So -2 squared is 4. 4 times -2 is -12 plus 8. 4 minus 12, that is -8. And -8 plus 8 is 0. So let's go ahead and find our y value when x is -1. So -1 squared is 1. 6 times -1 is -6 plus 8. 1 minus 6, that's -5. And -5 plus 8 is 3. So when x is -1, y is 3. And so now we can plot these 2 points, -2 comma 0, that's right here. And -1 comma 3, that's going to be right here. And now we can go ahead and reflect. So this point is 1 step to the right. Its partner is going to be 1 step to the left. This point is 2 steps to the right. Its partner 2 steps to the left. And this point here is 3 steps to the right. Its partner will be 3 steps to the left. And we draw our parabola. And we look for our zeros, which are right here. We have the point -4 comma 0 and we have the point -2, 0. So our solution to this quadratic equation is x equals -4 and x equals -2.